right. If you're an MBBS student getting ready for your exams, you know that high-yield info is everything. And that's exactly what this is all about. We're going to break down the Herpesviridae family into the absolute must-know points that are going to make a huge difference on exam day. Let's jump right in. So, if there's just one word you need to burn into your brain about this entire family of viruses, what is it? Latency. That's the key. You see, unlike a lot of viruses that your body fights off and gets rid of for good, herpes viruses are absolute masters of hiding. They set up a lifelong infection by going dormant in your cells, just waiting to reactivate later on. This one property, latency, is the foundation for understanding everything else about them. So over the next few minutes, we're going to hit 3 key areas. First up, we'll meet the different members of the family, and I'm going to show you a super simple way to classify them. Then, we'll check out their shared blueprint, the structure that all herpes viruses have in common. And finally, we'll get into a classic high-yield showdown, herpes simplex virus 1 versus 2. Okay, let's start at the beginning, figuring out who's who in this big herpes virus family. Nailing this classification is, I promise you, a guaranteed way to score some easy points on your multiple-choice questions. The entire Herpesviridae family is split really neatly into 3 subfamilies, and this is all based on things like how fast they grow and, really importantly, where they like to hide out during that latency period. You've got the alpha, the beta, and the gamma herpes viruses. Simple enough, right? Okay, so here it is, the official classification table. And I know, at first glance, it looks like a total nightmare to memorize. But don't even worry about it. I'm about to show you some incredibly easy memory tricks that will make this whole table a piece of cake. First up, the alpha family. This is as easy as 1, 2, 3. I'm serious. It contains human herpes virus 1, 2, and 3. That is it. Just think, alphas 1, 2, 3. Done. All right, next in line is the beta family. We're just going to continue the sequence, but we're going to skip number 4 for just a second. So the beta family has human herpes virus 5, 6, and 7. Another easy sequence to remember. So beta, 5, 6, 7. Got it? So what does that leave us with? The gamma family. And this one is just simple math. It's got the number we skipped, human herpes virus 4, and its double, which is 8. So gamma is just 4 and 8. And just like that whole scary-looking table is now just 3 simple rules. Now, let's connect those numbers to their common names, because that's another place people get tripped up. For HSV-3, which is varicella zoster virus, just think of the Z in zoster. Now, picture this. You draw a Z, then you just draw a line right through the middle, and what does it look like? A 3. With that little visual trick, you will never forget that HSV-3 is zoster. Let's do another one. HSV-5 is cytomegalovirus, or CMV. Start with the letter C. Now, imagine you just close the loop on that C and give it a little tail. What does it become? It turns right into the number 5. From C to 5. So HSV-5 is CMV. Trust me, these little visual tricks are lifesavers in an exam. All right, we've met all the members of the family. Now let's look at what they all have in common. We're going to dive into their basic structure, the herpesvirus blueprint. Check out this diagram. Now, the awesome thing here is that this basic structure applies to every single virus we just classified, from HSV-1 all the way to the virus that causes Kaposi sarcoma. If you learn this structure once, you know the morphology for the entire family. High yield, right? So let's break this down, kind of peeling it like an onion from the outside in. First, you've got the lipid envelope, and it's studded with these glycoprotein spikes that help it latch onto our cells. Just beneath that, you find this kind of unstructured layer called the tegument. Inside that, you have the super strong geometric icosahedral capsid, and right at the very heart of it all is the genetic material, a linear, double-stranded DNA core. Okay, now here is a critical point for your exams. How does this virus actually replicate? Remember that linear DNA in the core? Well, once it gets inside our cell's nucleus, it does something really clever. It forms a circle. And from there, it uses a very specific method to make copies of itself, called the rolling circle mechanism. You have got to remember that name, rolling circle mechanism. It is a classic exam question. Okay, for our final section, we're going to zoom in on the 2 most famous family members, herpes simplex virus 1 and 2. This head-to-head comparison is one of the most high-yield topics in all of virology, so let's nail it down. If you remember absolutely nothing else from this section, remember this one golden rule. Generally speaking, HSV-1 causes infections above the waist, think cold sores, and HSV-2 generally causes infections below the waist, so think genital lesions.
This simple distinction will get you the right answer on a huge number of clinical scenario questions. Now, this table just adds a little more detail to that golden rule. For your exams, let's focus on the most important differences. Check out transmission. HSV-1 is usually direct contact or saliva, while HSV-2 is mainly sexual or from mother to baby. Now look at the site of latency. This is absolutely key. HSV-1 sets up its hiding spot in the trigeminal ganglia, while HSV-2 hides out in the sacral ganglia. This difference in location is exactly why their reactivations happen either above or below the waist. It all makes sense.
And here's what that actually looks like in a patient. These images are the perfect example of that above-the-waist rule for HSV-1. On the left, you've got the classic vesicles, those little blisters, on the lips and tongue. And on the right, you see them around the eye. Both of these are textbook presentations of HSV-1. And it happens because that virus is reactivating from its hiding spot up in the trigeminal ganglia. So let's do a quick recap. You can now classify the herpes virus family with some easy tricks, you understand their fundamental structure, and you can confidently tell the difference between HSV-1 and HSV-2. But that leads to the next big clinical question, right? Once you think a patient has a herpes virus infection, how do you prove it? And what are you going to do about it? We'll cover exactly that in our next High Yield Explain.